Imagine being able to listen to the afterglow of the Big Bang. That's precisely what the cosmic microwave background, CMB, allows us to do. It's not just radiation. It's a snapshot of the universe when it was only 380,000 years old. Long before galaxies formed, before stars ignited, the universe was a hot, dense soup of particles and radiation. As it expanded and cooled, protons and electrons combined into neutral hydrogen atoms. In that moment, light was finally able to travel freely. And that light is still traveling today, stretched by cosmic expansion into microwaves. This ancient radiation now bathes the entire cosmos at a temperature of just 2.7 Kelvin, barely above absolute zero. But despite its faintness, the CMB holds extraordinary power. It is the oldest light in the universe, and it maps the subtle density fluctuations, ripples in the early universe, that later grew into galaxies, stars, and planetary systems. These tiny variations in temperature and polarization are the seeds of all cosmic structure. Without them, the universe would be a featureless fog. Today, the CMB serves as a cosmic backdrop, a standard reference against which all motion and structure can be compared. In fact, it defines a kind of universal rest frame. By observing how galaxies and spacecraft move relative to the CMB, scientists can measure true motion through space, not just relative to nearby stars. More importantly, the CMB provides a baseline for measuring cosmic expansion. It gives us insight into how quickly the universe is accelerating, and therefore into the effects of dark energy. But the CMB is not static. As galaxies evolve, their hot gas interacts with the CMB through a process called inverse Compton scattering. This happens when fast-moving electrons, typically found in galaxy clusters, collide with microwave photons, boosting them to higher energy levels. The result? Slight temperature increases in localized areas of the sky. These thermal distortions help astronomers map the distribution of hot gas across the cosmos and track the formation of galaxy clusters. In other words, the CMB isn't just a relic of the past, it's still actively shaped by the universe today. Precision measurements from missions like COBE, WMAP, and Planck have allowed us to detect these interactions with stunning clarity. These missions revealed a universe that is flat, homogeneous, and governed by dark energy and dark matter. They also gave us exact numbers. The universe is 13.8 billion years old, composed of roughly 5% ordinary matter, 27% dark matter, and 68% dark energy. But here's the irony. As the universe continues to expand, the CMB is fading, its temperature is dropping, its wavelength is stretching, and one day it will become so redshifted that even our most sensitive instruments may no longer detect it. Future civilizations, billions of years from now, may live in a universe where the CMB is completely invisible. They may have no direct evidence of the Big Bang, no knowledge of early structure, no access to the deepest origin of time. That's why our time is unique. We exist in an era where the CMB is still visible, still readable. A cosmic relic that allows us to study the past, map the present, and even predict the future. By analyzing its polarization patterns, scientists are also hunting for something even more elusive: primordial gravitational waves, ripples in space-time from the moment of inflation. If found, they would be the final piece of evidence for the inflationary model of the early universe. Triangulum, like all galaxies, formed long after the CMB was released. But the CMB still permeates the space around it. It is part of the cosmic weather that all galaxies experience, a silent, omnipresent hum from a time before time. Some researchers believe subtle CMB interactions may even play roles in fine-scale galaxy formation, especially in the early universe. In this way, the CMB is not just an echo. It is an active participant in cosmic evolution. As we look deeper into the fabric of the cosmos, we come to understand that light, even ancient light, still speaks. And the Siam speaks with the voice of creation itself.